Okay, hi and Assalamualaikum to Madam Zaidah. Today, my group member and I will be presenting about our fuzzy logic system, which is water irrigation system. Before that, we want to introduce ourselves. My name is ILYANA binti MUSTAFA.
My name is MARYNA binti GAMBAR.
My name is AINA SHAHIRAH.
My name is HAFIDZAHIDAH binti WANGIT.
Okay, now for the introduction of our system. We chose agricultural domain because it has a lot of potential in our country. Technology have helped those in the domain to ease their work, and hence, this is where water irrigation was built. But water irrigation has some problem with it. Although it was initially supposed to help farmers, yet it produced lower quality yield. This happened because the system does not pay attention to the uncertainties around the crop. Other problem is overwatering and underwatering, which can damage the crop quality. Lastly, evapotranspiration also occurs due to the unstable soil moisture. Hence, our objective is to create a water irrigation system that uses fuzzy logic to handle the uncertainties. To make our system possible, the first thing we did was gathering knowledge. Our main source of knowledge is through the internet. This is where we found our main source for this system, which is research paper prepared by Varun Khatri from NMIMS University titled Application of Fuzzy Logic in Water Irrigation System. For knowledge acquisition table, we have three factors with their function, associated problem, and as well as their symptom. I will only explain briefly the associated problem of each factor. The first factor is soil moisture. Soil moisture is essential to regulate soil temperature. If soil moisture is too low, then it can cause underwatering, which will result in soil become hard. Next is humidity. Humidity is to promote stomatal opening for photosynthesis. Dehydration can be caused by too low humidity, hence the plant will wilt. The last factor is temperature. Temperature is important for plant to induce water and nutrient uptake. Low temperature can cause rapid weight loss and rooting of plant. That's all for our knowledge acquisition. Now I pass it to MARYNA for knowledge presentation.
So for knowledge representation, this is our semantic network. And then this is our fuzzy representation table. We have 3 input and 1 output. The fuzzy variable are soil moisture, relative humidity, temperature, and valve opening. So the fuzzy subset for soil moisture are dry, normal, adequately wet, and saturated. For the fuzzy subset for relative humidity are low, medium, high, and extremely high. For the temperature are very cold, cold, normal, and hot. And for the valve opening are 10% open, 25% open, 50% open, 75% open, and 100% open. And the universe of discourse for soil moisture and relative humidity is from 0 to 60. The universe of discourse for temperature is from -10 to 60, and the valve opening is from 0 to 100. And the unit for the soil moisture is measured in centibars. For the relative humidity and valve opening are measured in percentage, and then for the temperature is measured in degrees Celsius.
Next is the linguistic variables. For variable soil moisture, the value dry has the range of 0 to 13 centibars. For normal is 5 to 24 centibars. For adequately wet is 18 to 35 centibars. And for saturated is 30 to 60 centibars. For variable relative humidity, the value low has the range of 0 to 20%. Medium has the range of 15 to 35%, and for high is 30 to 50%, and for extremely high is 45 to 60%. For variable temperature, the value very cold has the range of -10 to 10 degrees Celsius. For cold is 5 to 25 degrees Celsius. For normal is 20 to 40 degrees Celsius. For hot is 35 to 55 degrees Celsius. And for output, valve opening, the value 10% open has the range 0 to 20%. 25% open has the range of 15 to 45%. And for 50% open is 40 to 70%. and for 75% open is 65 to 85%, and for 100% open is 80 to 100%. For graph representation of soil moisture, all the value has the trapezoidal shape. For the fuzzy perception, the Y star represents when the degree of membership reach 1. This is the fuzzy perception of soil moisture. For graph representation of relative humidity, all the value has the triangular shape. This is the fuzzy perception of relative humidity. For graph representation of temperature, all the value has triangular shape except for value hot, which is in trapezoidal shape. This is the fuzzy perception of temperature. For graph representation of valve opening, all the value has triangular shape. And this is the fuzzy perception of valve opening.
So for fuzzy rules, we construct the rules by applying cube fuzzy associative memory FAM according to the number of values which are in the dimension of 4 times 4 times 4. So as you can see, there's a cube and then there exists consisting of soil moisture, humidity and temperature. So we obtain a total of 64 fuzzy rules which indicate the outputs, and then we slice the cube rules for a better understanding before using the rule editor in MATLAB to define the rules. So this is the slice 1 rules, which is for soil moisture, humidity and temperature equal to very cold. So we construct the rules as you can see at the above diagram, and then we encode it into the MATLAB as diagram below. So we do the same thing for rules slice 2, slice 3 and slice 4. So for slice 2, the rules is for temperature cold, for slice 3 for temperature normal, and for slice 4 for temperature hot.
Next is the sample input. For case A, we set the soil moisture to 11 centibars, relative humidity to 13%, and temperature to 19 degrees Celsius. And for case B, we set the soil moisture to 32 centibars, relative humidity to 41%, and temperature to 50 degrees Celsius. For fuzzification, case A, when soil moisture is 11, the graph touches the dry and normal value. Degree of membership for dry value is 0.25 and for normal is 1. For case A, relative humidity is 13. The graph touches the low value and degree of membership is 0.7. When temperature is 19, the graph touches the cold value and degree of membership is 0.6. For case B, when soil moisture is 32, the graph touches the adequately wet and saturated value, and degree of membership for adequately wet is 0.6 and saturated is 0.4. For relative humidity is 41, the graph touches the high value and degree of membership is 0.9. For when temperature is 50, the graph touches the hot value and degree of membership is 0.8317.
So for the rule evaluation, we use Mamdani style since it involves less complex and faster mathematics. So in our fuzzy system, we applied the n fuzzy operation intersection to evaluate the conjunction of the rule antecedents. So for example, for the case A, it fired two rules, which is rule 17 and rule 21. So I will explain about rule 17, which is if soil moisture is dry and relative humidity is low and temperature is cold, then valve opening is 25 open. So this is the mu. For example, the mu for soil moisture is dry is 0.25. For mu of relative humidity equal to low is 0.7, and the mu of temperature equal to cold equal to 0.6. So the output is valve opening is 25 open. Then we will choose the minimum value of degree of membership. For the rule 17 is 0.25. Then this is the clip of the rule 17. So same goes to rule 21, we will calculate and then we will choose the minimum value of degree of membership. So the minimum value is 0.6. So this is the clip. And also for example of case B, it fire two rules, which is rule 59 and 63. So just same with the case B, we will choose the minimum value. Then for case B for rule 59, the minimum value is 0.6, and for the rule 63, the minimum value is 0.4.
Okay, next aggregation. So for case A, we take the clip membership output from rule 17 and rule 21, and then the MATLAB combine the both output to form a one fuzzy set, as you can see at the bottom of the diagram. So the same thing goes for case B. MATLAB take the output of clip membership from rule 59 and 63 to combine a fuzzy set of aggregated output, as you can see at the bottom.
After aggregation, we can now look at defuzzification. For this, we use centroid defuzzification method to calculate the center of gravity for our aggregated fuzzy set. For case A, we have a simple trapezoid. We calculate it with a scale of 10 from 15 to 45 and the mu is 0.6. And we get the answer 30. So we can conclude that when soil moisture is 11 centibar, relative humidity is 13% and temperature is 19 degrees Celsius, then the valve opening for water aggregation is 30%. Next, for case B, we have a two combined trapezoid. We calculate it with a scale of 7 from 65 until 100. We have two different value of mu here, which is 0.4 and 0.6. Then we get the answer of 83.60. So we can conclude that when soil moisture is 32 centibar, relative humidity is 41% and temperature is 50 degrees Celsius, then the valve opening for water aggregation is 83.60%.
So this is our coding in MATLAB. So the first one, label the system of magnetic inference system, and then we give the name of irrigation. Then we add the input. So this one is the first input, which is soil moisture, which has the fuzzy values of dry, normal, adequately wet, saturated. And then we repeat the steps for input second, which is relative humidity, and then input third, temperature, and then we add the output, which we has only one, which is valve opening. We enter the values which is 10 open, 25 open, 50 open, 75 open, and also full open. And then we assign rule list variable to enter the rules. So the first one is the first input, second input, third input, output, weight, and also our fuzzy operator, which is n. And then we enter all for 64 rules, and then we add the rules into our system.
Okay, now we will see the graph for our membership input. The first input is soil moisture. Okay, we can see here the graph for membership function soil moisture. We have 4 fuzzy subset here and all in trapezoid shape. Next, we will see the graph for relative humidity, our second input. Okay, we can see that the graph have 4 subset too. It all in the triangular shape.
So our third input is temperature. And then this is our graph of membership function that have 4 subset, consists of triangle and trapezoidal shape. And then lastly is for the output, which is valve opening. So this is our graph for membership function that have 5 subset of triangle shape.
Next, we will show the rule viewer. The first one is our case A, where soil moisture is 11, relative humidity is 13, and temperature is 19. And the output is 30% open. Our case A fires rule 17 and 21. Next is our case B, where soil moisture is 32, relative humidity is 41, and temperature is 50. The output valve opening is 83.6% open. This case fires to Rule 59 and 63. Okay, that's all from us. Thank you.